Today we're presenting our restaurant reservation system, a client-server application for managing restaurant bookings. Our system lets customers create accounts, browse seating, make reservation, and process payments. Restaurants can configure seating, pricing, and hours. The system uses a threaded server architecture to handle multiple clients and ensures data consistency with a file-based persistence. Manual reservation systems are error-prone and don't scale. Our system automates booking, prevents double booking, handles payments, and provides a simple interface for customers and restaurant staff.
Our system includes secure account management with password validation, a GUI with custom input fields for dates, emails, and phone numbers with real-time validation. The reservation system supports seat selection, time-based conflict detection, and automatic cost calculation based on seating sections like VIP or standard. We also implemented secure payment processing with card number validation using a LUN algorithm, server-side configuration for seating arrangements and pricing, and a threaded server that handles multiple concurrent clients. And all reservation data is persisted to disk so information survives even when a server restarts.
Our architecture follows a client-server model. The client GUI communicates with a threaded server that processes requests. The server manages account files, reservation databases, and configuration settings. We use serialization to persist reservation data and file input-output for account storage. The system is designed to be thread-safe, using locks to prevent race conditions when multiple clients access the same data simultaneously.
All right, so now we're going to do a short demo of our reservation manager. So to start off with, we have a owner-side GUI for setting any server-side settings. Pulling that up right now, and we can see that we have an hours of operation and a seating arrangement settings. So we have some default values for the hours of operation. As of right now, it is from 9 in the morning to 10 at night. We can, the server user or like the owner of the restaurant can set it to, let's say that this restaurant opens at 11 in the morning and closes at, let's say 5 at night. So, which actually let's do 10. And then we can see that our current hours have updated to 11 in the morning to 10 at night. And if we try to do something like, say, something valid, you can't set the hours and it just throws an input error. So change that back right now. And then we can set the seating arrangement to a grid. So as of right now, we have 5 by 5 seating arrangement. We could do like resetting the columns to maybe like 10, and we would have a 5 by 10 seating arrangement. So we use set seating arrangement to set these seats. And if, for example, the seats are incorrect, you can do a load seating, which if I put in like something like 11, if I load seating, it loads back to 5 rows and 10 columns. And as right now, we have a default price of 35.91 cents. The server user can use the default price to set all of the prices to a default price. And because this is, of course, in dollars, if you set it to like 40.111, where in dollars you only have realistically 1 cent, it really just sets it to 40 and 11 cents. And you can go into any one of these seating arrangements. And for example, we go into C4 and we change it to, let's say, 45. And that sets C4 to C4 to 45, while all of the other seats are at 40. This could be really useful when the owner wants to like set like VIP seating and things like that, right? So yeah. So after configuration, after configuring the server, we can start running it. So we can run the server, and when we get the server up, the users can actually start logging in. So let me pull up a user. Let me pull up a user interface, give it some time. Okay, so now we have a user client. As of right now, we have a few test accounts in, but I will show you the entire login and create new account process. So when we were logging in, the user is prompted with, of course, a username and password. If we have, let's just say, let's try something random here with some random password, we can see that you can't log in because the account doesn't even exist, and or your password is incorrect, right? You can show the password using the show password button. So as of right now, we have, we'll go ahead and create a new account to log in. So when we're creating an account, the user has to enter, of course, their personal credentials. We'll just use something for testing, right? And we can do like something like first name, last name. For the email actually has to be a valid email, which means it has to be something at something.com or .co or .org. If you were to put in something like a, and then you wouldn't be able to create your new account. As of right now, since the phone number and birthday are also invalid, it's going to throw the phone number first. But for example, we set the phone number to something, some actual phone number, and our phone number actually tests for error code, which means that you have to have a valid error code for your phone number to exist. So, for example, if you want to set the phone to something like 000000000, you wouldn't be able to create your account because the phone number is invalid. So now we can put in an actual area code, and then the phone number can be anything starting with 1, of course. And then we can input our birthday. Now our phone number is valid. We can make sure that our phone number is valid, and then to input a test username here. Um, and now you can see that because we don't have a birthday, the birthday is invalid, so the user has put in an invalid birthday. If we were to do something like, you can't type any letters in the phone or the birthday fields because of a restriction set by our code. So, but you can type in numbers, right? And if you try to do something like month 13 with day 21 and year 2000, you wouldn't be able to because your month, it has to be between 1 and 12, right? The date has to be valid. So let's use a valid date. All right, now as you can see, we have a valid phone, a valid birthday, and a valid username, a valid first name, and a valid last name. So now if we try to create the account, of course, we don't have a password in our email field right now. Let me change the email back to A. We can see that the email is in fact invalid because it is not at something.com. So let's just do a test at test. Even if we just have a test.test, you can see that we still can't create the account because the email is still invalid. In the email field, you can't type any spaces because that's usually how email fields work. So we're just going to do test at testmail.com, which you can see now that the email is valid. It prompts you to create a password that has to have at least 8 characters. And so we could do like something like test 1, 2, 3, 4 with a capital T. And you can see that it doesn't allow you to create a password because your password has to have a special character. If we do something like with only special characters, the password is still invalid because you have to have a number in your password. You have to have both capital and lowercase letters. And it also has to be between 8 and 16 characters. So if we were to do something like test at 1, 2, 3, you would be able to create the account. Of course, the passcode is completely encoded here. So if you do type something incorrect, well, perhaps you have like an extra 5 or something. You wouldn't know. That is a downside, but the upside is that no one can hack your password because it's completely blocked from view. And of course, because I've already created the test user account, we can't create another account called test user. So if we change it to something like example test user 2, you would be able to create the account because the test user 2 has never been created. I forgot the email, sorry. Okay. So now we've created this account, we can try to log into it. So we have test user 2 as our account, and our password is test at 1, 2, 3, which now you can see that you have successfully logged into the reservation manager. And if you were to try to log in on a different, let me open another, I'll relog in again. 2, 3. You can see that it's already logged in on another device. This is because I've already logged in on a different login, but because that login was stopped directly by the code itself, there wasn't a logout function called, which makes it stuck. This is really just something that happens um, when you're forcing a stop by code, which isn't going to happen when you're actually using the login. But let's just suppose that that page was still open, and you can see that you can't log into the same account. So let's close this page now, and let's log into another account because that account is apparently locked out because of Virtual Studio Code. And you can see that you can log in here. And let me do this correctly this time. And if you try to log into this account again here, you can see that it's already logged in on another device. However, if I were to close the reservation manager here, you would be able to log into this one because I closed the instance of the reservation manager correctly on the other page. Also, if you click log out, it works the same way, and you would just have to log back in. All right, so after logging into the reservation manager, we have a My Reservations page where you can book reservations. I've already booked a reservation with this account, so you can see that you have a reservation here at table A at 12. If I cancel this reservation, it says reservation canceled successfully, of course, and then you have no. All right, and so to make a reservation, we would have to go into the view seating arrangements page, where you can see that this is the seats that the reserver can see. For example, we can go into seat B2, and we want it to be, of course, we have it to at least December 7th, right? If you try to go into like December 6th, you can see that you can't make any reservations at any time. So it has to be the current day where you can make a reservation. So we can try to make a reservation at, let's say, 5. And yeah, you're prompted with a reservation details and the amount that you have to pay. So now you would input your card number. We have a few cards here that are for testing that work correctly. I think this is 16. It's not, it's 15. Actually, I'm gonna remove one. All right, and you can see that the payment failed because the card information is incorrect. If we were to make the card information correct, then you can see that your payment would be successful. And that once your payment is successful, your reservation is created, and you can go back to the seating arrangement and view your reservations. And you can see that you have reserved table B2 at 17 on December 7th. Please ignore this table A because because I kind of messed up and I redid this. And then you can cancel this reservation if you need, and you would have no reservations. And then when you go to the settings, of course, you can, you're prompted with a few choices. You can edit your profile. With everything in the settings, you would have to input your password before you do anything. And when you get into the settings, you can see that you can, of course, edit your profile. Let's make our birthday this, and the mail email can be the same, and we can update our info, and it's successfully updated, and you're redirected back to the settings. You can also change your password. Your original password was test at 123, right? And then now I'm changing it to something like test at 1234 exclamation mark. And when you to show you this, I'll have to log out, and I'm going to log back in. And we can see that if I click log in, now the new password is correct. And if I were to try to log in with the previous password, then you wouldn't be able to log in anymore because it was updated. Finally, you can delete your account if you wanted to, which we don't recommend this, but you could. And so you would just have to input your password and then click OK. And then it prompts you again to make sure that you actually want to delete your account. And then if you click yes, then your account is deleted successfully and you're returned to a login page. If you try to log in with your account, you can see that you're unable to log in anymore. All right, that is all for our demo.
To ensure reliability, we created a test suite with over 117 test cases across 18 test files. Our testing strategy covers unit tests for individual components, integration tests for client-server interactions, and concurrency tests to verify thread safety. We tested account management, reservation operations, payment processing, input validation, and error handling. We have tests for all UI components, data field, email field, and phone field, ensuring proper validation. Account data tests verify setters and getters work correctly. User client tests covers the full account lifecycle from creation to deletion. Payment processor tests validate cost calculation and card number validation. Server tests ensure proper handling of concurrent account creation and data persistence. Some other notable tests include our concurrency test that simulates 10 threads trying to create the same account simultaneously, ensuring that only one succeeds. We also have a comprehensive password validation test covering all types of edge cases. All tests use JUnit and can be run automatically to catch regressions.
From a technical standpoint, we're proud of several achievements. Our threaded server architecture efficiently handles multiple clients without blocking, and we implemented proper synchronization to prevent race conditions. The GUI provides real-time validation feedback, and our payment system uses industry-standard validation. And our test suite gives us confidence that the system works correctly under various conditions.
How does your system handle concurrent reservations for the same seat? Our system uses a thread-safe reservation database with read-write locks. When a client requests a reservation, the server acquires a write lock, checking for conflicts and either adds the reservation or rejects it. This ensures that even if multiple users try to book the same seat at the same time, only one will succeed. We tested this with our concurrency test that simulates these simultaneous requests.
What happens if the server crashes? Do users lose their reservations? Data persistency was a priority. All reservations are serialized to disk immediately after creation. Account information is stored in text files. When the server restarts, it automatically loads all reservations from the disk. We tested this by creating a reservation, shutting down the server, restarting it, and verifying all data was preserved.
How scalable is your system? Can it handle a reservation with hundreds of seats? Well, our system is designed to scale, which means that the server configuration allows restaurants to define any seating arrangement, from small cafes to large banquet halls. The reservation database uses efficient data structures, and our conflict detection algorithm checks only relevant time ranges. The threaded architecture means that the server can handle many concurrent users.
Building the system taught us valuable lessons about software engineering. We learned the importance of writing tests early, the challenges of concurrent programming, and the complexity of building user-friendly GUIs. We also gained experience with client-server communication, data persistence, and payment processing validation.
In conclusion, we built a restaurant reservation system that automates booking, prevents conflicts, processing payments securely, and provides us a smooth user experience. With over 117 test cases, we're confident in its reliability. The system is ready for deployment and can be easily customized for different restaurant needs. Thank you for your time, and we're happy to answer any additional questions.
On the